Welcome to Big Data Analytics ISC 4172. This is a course designed for senior undergrad students and the first and the second year graduate students. What we're going to do is we're going to cover a lot of fun topics related to big data. So when you have a large enough data, then there's a lot of fun problems occurs. So throughout the semester, we're going to talk about theories, principles, some mathematical tricks, or even practical computing skills to handle and deal with the big data problems. So since today is the first day, we're going to go over some of the logistics. So, well, before getting started, my name is Steve Beck. For those of you who are late, I'm an assistant professor of industrial and systems engineering at the University of Iowa, and I'll be your teacher for this course throughout the semester. Just to talk briefly about myself, I'm a researcher interested in finding linkages between shapes and some natural or engineering phenomena. So for example, it is known that the tumor shape, so the cancer patients, the shape of the tumor has some correlation with cancer survival. So what I do is to apply machine learning to quantify what exactly such a correlation is and how they really look like. There are many other examples. One of the most recent result is in materials research. So when you look at the things through a microscope, you'll see a lot of different, interesting shapes. Those are called microstructures or nanostructures. And interestingly, these small structures determine the physical behavior of a material at a macro scale. So the idea is that, we can manipulate the microstructural geometry to engineer the behavior of a material. So to do all this kind of, research, what I use is tools of machine learning, big data analytics, so that we can derive some physical or biological description of a behavior from data. Okay, so that's basically what I do for my research. For this semester, I'll make myself available to help you out every Friday from 2 to 4 p.m. The office hours will be held virtually, so the Zoom link is posted on Icon. Again, this is an unfortunate situation because I really enjoy engaging with students and talking face to face and helping you guys out. But I guess this is what it is for this semester. I'll do my best to serve you guys despite of those constraints, and then and in fact, I've done this last semester, and then I taught deep learning last semester, and then the interaction virtually was not too bad. And in fact, I could make myself more available because, when the things are digital, I can probably better manage and make it more efficient. So the Zoom link is posted on Icon. Again, Friday 2 to 4 p.m. Is my office hours. So if you have any question or anything to chat about the course or something else, feel free to drop in and say hi, and then I'll be there. Okay. We have a TA for this course. Joseph Choi is my PhD student. He's are you here, Joseph?
Yep, I'm here.
Hey, how's it going? I guess you have some feedback. So yeah, why don't you just get muted? So Joseph is my PhD student. He's currently, are you already third year now? Yeah, time flies. Okay, so he's a third year in PhD in industrial and systems engineering. And he's an excellent programmer. He's very good at computer programming, and he has a lot of experience with medical AI, machine learning, and those kind of things. So he'll be available, in fact, immediately after the class. So the class is 3:30 to 4:45 every Tuesday and Thursdays. his office hours is going to be right after that. So 4:45 to 5:45 every Tuesdays and Thursdays. So if you want to hang out and chat with Joseph, there is actually a Zoom link on Icon for Joseph's office hours. So basically all the information is in on Icon. So you can go ahead and check his office hour links. Okay. Throughout this semester, we're going to learn a lot of different topics, including data mining, machine learning theories, and a lot of different things. Especially, we'll be talking about machine learning algorithms in big data version. So one example of that is consider a linear regression problem. Okay, so if you're already familiar with what linear regression is, that's great. But even if you're not, that's all right. We're going to cover that. But linear regression is basically a problem where you're interested in finding the correlation between a variable X and a variable Y in an assumption that their correlation can be represented as a linear equation. So I'm going to write something down over here. So y equals to x ax is basically the relationship that we're assuming mathematically. And then the problem here is we have data set for y, the data set for x. So x and y are knowns. And then the unknown is the matrix A. So A is something that we're interested in figuring out. Now the dimensionality of A is dependent on the size of data. Okay, so if the data size n is really big, then the matrix A is going to be really large. And then if you think about it, in order to solve this y equals to ax problem, you have to compute an inverse, or what is called a pseudo inverse to be more precise. And then the pseudo inverse is, the computational complexity of the pseudo inverse operation is dependent on the size n. So if you think about it, when the number of data that you have gets really large, then computing inverse is going to be computationally very, 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 very heavy. You see the spirit. So and then even worse is when n is like crazy high, then what's going to happen is A is too large that fitting that into your RAM is going to be problematic. So if you're not a computer scientist, a simple, description of how computers work. So you have a central processing unit called CPU, and then the CPU has a temporary memory that is called a RAM, random access memory. And then you have a hard drive. Hard drive is a permanent memory, and then RAM is a temporary memory for a rapid access. So what happens is your data is stored in hard drive. The data stored in hard drive is permanent until you explicitly delete them. Now, when you want to do the computation, what you're going to do is you're going to read the data to the RAM, and then your CPU is basically going to access the information in the RAM and then do the computation. Okay. Now, the size of the RAM is typically, I don't know, 16 gigabytes nowadays, 32. Do you guys have a computer that's any bigger than that? Maybe gamers have much bigger memory, like 64 gigabytes. I've seen 256 gigabytes in my colleague's office computer. That's like a $4,000 beast. But I guess for an ordinary computer, we're talking about 16 gigabytes, 32 gigabytes, or 64 gigabytes. I think that's kind of the maximum. So if you think about it, if the size of n is really, really large, let's say you have billions of data points, right? So then you may want to be able to host a billion by something matrix, right? And then you have to put everything on the RAM in order to be able to do the computation, which is going to be impossible when the data size n is really large, right? So what would you do in that case? One solution is obviously to buy a supercomputer, right? Which is really expensive. And then, you know, supercomputers may have much, much larger RAMs. But, you know, if you think about the size of data nowadays, even a supercomputer will not be able to handle such a large data. So what happens usually in the big data systems is that we distribute the computing load to multiple computers, okay? So we have now multiple computers, each having CPU and a RAM, and then you need to somehow distribute the computation of y equals to ax to those multiple computers. So how would you then do that, right? So you will not only need to understand the mathematics behind it, because there are obviously some mathematical tricks that's, you know, taking place in order to make this possible. But in the meantime, you need to be proficient with the technology that enables that. So the third and the fourth bullets are basically for that. So we're going to talk about some mathematics of machine learning in the context of big data, so that we have some mathematical theories to enable distributed computation of a large data set, or more efficient computation of a large data set, and so on and so forth. We're going to also talk about this technology called Hadoop and Apache Spark. I don't know how many of you have heard Hadoop and Spark. Those are the hottest technology nowadays, where which is demanded by a lot of employers. So a lot of IT companies, a lot of startups, a lot of you know, big companies requires Hadoop and Spark as kind of a necessary skill set for data scientists and data engineers. So we're going to talk about all this fun stuff throughout the semester. All right, so there are a couple of prerequisites. First thing is the probability and statistics. Especially, I will assume that you're already familiar with the basic concepts like a probability, conditional probability, Bayes theorem, random variables, what the expectation is, the variance, and, you know, those kind of a basic concepts, as well as distribution, especially like uniform distribution, Poisson distribution, normal Gaussian distribution, and so on and so forth. And then we're also going to talk about the statistical hypothesis, and then statistical significance. So I believe those topics, you've already covered them in Stat 2020, which is the prerequisite of this course. However, I will not assume that you are super familiar with those contents, because I know this is a senior level or a graduate level course. And then probably you have taken Stat 2020 when you're a sophomore year. And I guess you already have forgotten quite a bit of those concepts. So my recommendation is to take a look at, you know, pick up the book and take a look at those concepts, and then just quickly go through to brush them up. But even if you're not so familiar with these concepts, don't worry. Whenever, you know, those keywords pop up, I'll try to briefly explain what it was, so that you can follow this course without too much effort. Another prerequisite is a basic programming skill, and this is important. We're going to use Python, and Python is going to be the major programming language to be used in this course. So all of the homeworks, all of the quiz, examples, exercises, everything is going to be done in Python. So if you're already comfortable with Python, then that's great. If you think you're already proficient with Python, then that's fantastic. If you're not, then here's the deal. So on Icon, I created this quiz problem. I don't know if you can see this screen. So if you go to Icon, there's this menu under Module 1 that says Project 1 Basics of Python quiz, okay? So that's a quiz that is assigned to everyone for your skill test. If you can pass that quiz over 80% of the score, then you should be good. Okay, you don't have to worry about Python, at least in this course is concerned. Okay, if you cannot pass that quiz, then that's a good reason to take this optional module called the Python Basics. Okay. Now, the assumption here is that you guys are already familiar with at least one programming language. Okay. So I'm assuming that you are already familiar with at least one programming language, including C++, C, MATLAB, Java, R, or something else. Okay. So in that Python lecture, I'm not going to talk about all the basics of computer programming. I'm not going to talk about how the memory works, what the variables are, and those kind of basic stuff. Instead, in that lecture, that's roughly about 100 minutes of lecture. I will just quickly go through some of the important Python syntheses, and then we'll compare them with the languages you are already probably familiar with, like C++ or MATLAB, so that you can quickly pick up Python. Okay? Now, if you are concerned about your programming skill, I would recommend you to talk with me. Okay, so you can send me an email, or you can just come to my office hour on Friday. But before to do that, try to take the quiz. Okay, the quiz, you're going to be allowed to make infinite number of attempts, so there's no limitations. So even if you fail for the first time, that's all right, because you'll have another chance to take the quiz again. And then you can, in fact, take the quiz, like infinite amount of time. So until you have a score that, is satisfactory. So, don't be afraid. Just take the quiz and, for your self-assessment. Okay. And then if you're concerned about your skills, then I recommend you to send me an email, or come to my office hour and discuss your future plan. Okay. All right. So that's about prerequisites. The final thing about the course logistic is the grading policy. This class will not have paper exams. Yay. So we're not going to take the paper exams. Everything is going to be based on the quiz that you take and the projects. And the weighting of quiz and the project is going to be 30% and 70%. The quiz problems are going to be assigned after each module. And then we have about 7 and 8 modules. So we're going to have total 7 to 8 quizzes. For project, I'm planning for 4 different projects. The projects are going to be called a consulting project. So this is something I'm trying for the first time this semester. Usually we've done a semester project where at the end of the semester, each of the group present, a problem that they worked on, and then, have a discussion and, things like that. But I guess with the current setting of virtual instruction, I guess having that kind of, group project is not going to be ideal. So instead, there's going to be an individual project that each one of you have to work on. And the project problems are going to be an open-ended problem. And we're going to assume that we are data scientists, and then we have a client who has a data problem. And then your client is going to give you their data set. And then your mission is to analyze the data and then report the analytics result to your client. So we're going to pretend as if we're dealing with a real client. So I think it's going to be a lot of fun. And then I think it's going to develop you a lot of practical skills, because we're going to assume a real world, data analytics scenario. So So we're going to have a lot of fun with that. Another thing I want to mention is that the quiz, the weighting is only 30%, and then the project is obviously much larger than that. So you probably want to spend more time on the projects, okay? And again, the projects are quite open-ended, so there can be many different answers. There's not a single textbook answer. There's going to be a lot of different answers. So my TA and I are going to grade all of them and then evaluate the projects and then, rank them. And that's how your project score is going to be determined. And then the quizzes are, automatically graded on Icon. So it's pretty straightforward. Now, one last thing I want to mention regarding grading is that this course has a no tolerance policy on cheating and plagiarism. And like I said, especially the project, there's no way two different individuals can come up with exact same solution, okay? Because the problems are open-ended. So you must submit your own answers. Otherwise, it's going to be a violation of the academic conduct policy of this course. And in the case, it will be reported to the dean's office and, so on and so forth. So things can get really ugly. So don't even, try it. It's not worth it. Okay. And at the end of the day, I'm pretty, I don't know if it's a good thing to say at the beginning of the semester, but I'm pretty generous when it comes to final grading. So again, it's really not worth it. Okay. So today, as an introductory session, we're going to talk about some of the basic concepts on big data. Here's an interesting quote I borrowed from my colleague. And the quote is depicting how astronomical the amount of data we accumulate every day. So it reads, every day we create 2.5 quintillion bytes of data. So a quintillion byte is 10 to the 18th byte. And it's also called, let me write down something. It's also called an exabyte. So 1 exabyte is a 1 billion gigabytes. It's also 1 million terabytes. So probably if you have a brand new laptop or something really nice, then the size of your hard drive is going to be 1 terabyte or 2 terabyte. And 2.5 exabyte means 2 million terabytes of data. And that's the amount of data that we're accumulating every day. So that's a large number of data. And how large it is explained by the next phrase, so much that 90% of the data in the world today has been created in the last 12 months alone. So if you think about it, this is the total amount of data that the entire world has accumulated throughout the history. Well, this quote is from 2014, so up to 2014, right? And 90% of the data. So this is only the 10%, and 90% of the data, okay, has been accumulated in the last 12 months. Okay, let that sink in. That's a large number of data. Okay, can you see that? Now, interestingly, if you, where's my cursor? Oh, there we go. So if you go to the year 2015, there's some change in the statistics. Okay, now the percentage here has been changed to 95%. So again, if this is the amount of data that's accumulated by the work, by us, 95% of the data has been accumulated in the past 12 months, okay, with respect to the year 2015. And that includes the year 2014. So if you think about it, that's a hell lot of data. If you go to the next year 2016, now the numbers are the same, but the number of month has been reduced to 9. So we don't even take the full 12 month anymore. It only requires only 9 months to create 95% of the data in the world today. And then if you go to 2017, the number of month has been further reduced to 6 months. So you only need a half a year to create 90% of the data in the world. And that's the data, that's the statistics back in 2017. So I haven't followed up on this after since that, but you can easily imagine by this time now, especially nowadays where everything is virtual, right? The total amount of data that we're creating today is going to be way, way larger than what's described in this quote. So that is kind of the problem that we're talking about. Now, you may ask, aren't they just a large number of data at the end of the day? So why are they so special that it deserves a course that is a semester long, right? Can we just apply the usual machine learning algorithm, maybe with a faster computer with a bigger hard drive, right? I mean, that's a valid question. And my answer is no, that is impossible. Because big data is, in fact, quite different from conventional data in the sense that they're not only substantially larger than conventional data, but also they increase at a faster speed and has a significantly larger heterogeneity. So, for example, big data problems nowadays, like I said earlier, cannot even fit on a single computer. Okay. Instead, oftentimes what you need is like a cloud of storage or a huge, gigantic network of multiple processors and multiple storage devices to handle big data problem. So that's one thing. The other thing is, well, the speed of growing is really incredibly high. Like in the quote that we saw in the previous slide, right? The growth rate is so incredibly high. So that machine learning model, let's say you have already large data, and then somehow using supercomputer, HPC, or whatever, somehow you manage to process all the data, and then you train the machine learning algorithm. But while you are doing that, okay, there are a ton of additional data that newly arrived. So what are you going to do? Are you going to then discard the machine learning model and then train the model again with the new data? Probably not, right? Rather, you want to be able to adapt your machine learning model with the additional data set while minimizing the total number of computations, right? So the growth rate is actually another problem with big data. And finally, since we have a large number of data, data are typically unstructured and heterogeneous. So it can include a lot of different data generation modalities like sensors, which create waveforms, right? Audio signals, videos that you upload on Facebook, things that you post on Twitter. So that's a natural language data. Autonomous vehicles are generating lots of 3D point cloud data. So there are so many different heterogeneous data. And then the data is pretty dirty because there's no practical way to process all of them. So in the typical big data scenario, you have the data set that is really dirty, lots of missing information, lots of unprocessed, unstructured data, lots of noise included. And again, there's practically no way for you to go over all the data points and then, make them clean and, nice. So you somehow need to have a strategy or an algorithm or, or technology to deal with, those complicated, sophisticated, and heterogeneous forms of data. So what I just described, okay, there were three things, Okay, those are actually called the 3 V's of big data. And this is very important, okay? 3 V's. So the first V is volume, okay? And the volume means the sheer size of the data. So, and this is obviously, what a lot of people are already familiar with. Big data, it sounds like big, right? So volume means, how big, how the sheer volume of data, how large is the sheer volume of data. So for a usual machine learning problem, like I mentioned earlier, data is loaded onto the RAM, and then CPU can access the numbers and values already loaded up to the RAM. But in case you have a large volume, then it is impossible to fit the numbers into the RAM, and that can create a lot of problems. So that's the first V. Now the second V is velocity, and velocity means the rate of growth of data. So it literally means how fast the data is accumulated, and regardless, okay, of your current situation. So even if you have a small data set at this point, if you expect your data to grow at a fast rate, then you have a big data problem. Okay. So one good example is that is the self-driving cars. So a self-driving car collects various kinds of data. Okay, from 3D point clouds, computer vision data, sensors, and GPS signals. A lot of different things are coming in real time. And then the rate of data collection is so high that it collects anywhere between 1 terabyte to 20 terabytes per hour. Okay, so in 1 hour, your hard drive is going to be more than full. Okay, by the data that is generated by a self-driving car. So that's a huge velocity. And if, let's say, you're a data analyst working for Waymo, it's a self-driving car company, right? You need to actually multiply that number by 200, because you have not only a single vehicle, but you have a fleet of different vehicles. So that means you're, collecting data which size is 2.2 petabytes to 30 petabytes a day. Okay, so if your data is expected to grow at this much of astronomical rate, then you have a serious big data problem, because keep adding hard drive is going to be practically impossible, or waiting until a full set of data is accumulated and then do the lazy update on your machine learning model. Again, that's not going to work, right? So you somehow need a capacity to handle all this real-time stream of data, and that's what the velocity is all about. Finally, the third V is variety. Okay, so the self-driving car example again. The type of data that a car collects not only includes some, sensor readings, but it can include also like a GPS data or a 3D scan data, using LiDAR sensors. The self-driving cars, kind of 3D scan the road in real time. Of course, self-driving cars have lots of cameras, infrared cameras and vision sensors and things like that. So you have a live stream of videos right there. And another example, if you think about like a Facebook or Twitter, users post all kind of different contents, right? They post texts, obviously, photos that they have taken with their friends and families, right? Videos. That's another popular contents of social media platform. Nowadays Facebook support 3D contents, so you can upload a 3D image on Facebook. So that's another type of data. Audio is another form, and you can nowadays post a lot of different things on social media. So a big data platform that sits inside of Twitter or Facebook, they must be able to handle all this kind of different data, because otherwise you'll never be able to even digest, the data that you're accumulating. Okay, so for those highly heterogeneous data, you can easily say you have a big data problem, and therefore you need a more sophisticated analysis framework than those conventional machine learning problems. So what I have over here are the links to some interesting videos. Those are really good videos that I've cherry picked from YouTube. So I highly recommend you guys to take a look at them. Those are really interesting topics, especially the first video is going to be quite informative. Okay. And then the other three are more or less on the interesting application of big data analytics, especially, I guess, the last one, since we're getting close to the election day, right? So a lot of people will be interested in knowing how big data actually helped the US election. So that's based on the story of, not the current election, but the previous presidential election in the US. So those are all very fun videos to watch, and I highly recommend you guys to watch all of them.
Professor, can I ask a question?
Yes, sir.
Just to give you a chance to take a vocal break and let you know that there's some of us out here still awake. So
I appreciate that. I actually wanted to drink some water.
Yeah. I watched a couple of these videos, and I don't know if it was in one of these links or a follow-on that, YouTube just follows up with something related sometimes. They talked about two other V's, the veracity or the truthfulness of the data, big data, and value. I don't know if you have any further remarks about that, but that was just something that I saw. And then if you do a Google search, those also pop up for instead of the
That's an
3V.
excellent question. Yeah, that's an excellent question. So depending on the authors, some people call it 4 V's of big data. Some people call it 5 V's of big data. So you will notice, actually, if you've done already some Google search, there are actually, other definitions than 3 V's. But in my opinion, 3 V's are the most fundamental ones that are agreed by a lot of different people. And then depending on the textbook, depending on the material that you're reading, some people prefer to say like 4 V's, 5 V's as kind of an expanded definition. So, but even with those definitions, I'm pretty sure they all include this, 3 V's. So, these 3 V's I introduced in this lecture, those are the most fundamental ones. Does that answer your question? Perfect.
Yeah. I probably didn't need to raise it. It was just more or less to let you talk a little bit about it. I'm also seeing some authors and some sites here even talk about 7 V's, and they go into visualization and variability and also other V words. So yeah, I just
that's right. Well, you have to sell a book, right? You have to you have to have something new. So I guess people want to add more V's, right? To show off their, I don't know, their vocabulary or whatever. But again, I think those 3 V's are the most fundamental ones. So that is, in fact, a very good question, because I don't want you to be confused by some other definition. Even I think it's been a while, but I think even the first video in the lecture slide is going to mention 4 V's. Okay. So don't come to me and say, hey, you told me it's a 3V, and then the video says 4V. What the hell is going on? Again, that's an extended definition of the essential components of big data. So it's always good to see those different definitions, because it gives you a different perspectives. So very nice question. Any other questions? If you're too shy to speak up, there's a chat box. You can, I don't know which button you have to click, but in my case, I think I just hit Alt-H. All right, so I'll leave the chat window open. So even during the lecture, if you have any question, please go ahead and type something. Now, this is actually the end of today's lecture. So I'm kind of going back to the initial slide, the course overview slide. So I said we're going to talk about some basics of data mining and machine learning. And then I said we're going to talk about some big data versions of machine learning algorithms, and then some working knowledge of big data analytics using Python. So given all what I explained, the 3 V's of big data, okay, the main objective in this class, in this course, is going to be, learning both theoretical and practical skills to handle those 3 V's of big data. Especially at the beginning, we're going to talk about the first V, the volume, okay, because that's obviously the most important thing. So to do that, actually, maybe hopefully from this week or next week, we're going to start talking about Hadoop and Apache Spark. Those are the practical tools that you can use to set up a big data system. And what's really cool about it is you don't need to have a super duper computer. Hadoop can be installed on commodity hardwares. So commodity hardware means that it's, just usual ordinary computers, okay, that you have in your home or office. And using those commodity hardware, you can set up a big data system. So that's kind of cool, right? So we're going to talk about Hadoop and Apache Spark at the beginning, and then we're going to make sure that you all kind of understand and have some working knowledge about how to handle a large size data. And then later on, we're gonna, talk about some adaptive machine learning algorithms to handle data with high velocity. And then we're gonna talk about some data streaming functionalities in Apache Spark, which is, again, really useful tool to handle real-time data. And then for variety, I guess, for that, it's kind of tricky to cover in this class because to handle the variety of data, you will need to know and understand different domain-specific problems. But I guess the projects and examples that we're going to use in the class are going to contain a lot of different, modalities of data, a lot of different heterogeneous data samples. So yeah, so like I said, we're going to have a lot of fun with those 3 V's. So yeah, so that's it for today. I guess it's a little bit early, but thank you very much.
I do have another question if we can hang on for a second.
Yeah.
For the course, will everything that we do in terms of our projects and such be, what should you say, academic, or is there some equipment in the labs where we can actually do empirical studies or actually run some of the tools? I guess I used to be a sysadmin for a while, and it's really always interesting for me to see how the tools work. But is that possible?
Excellent question. Yeah, excellent question. So what we're going to do is 2 things. The first thing is we're going to take a look at how to set up Hadoop in a virtual environment. So obviously, it's impossible for everyone to have an access to a Linux computer. So Hadoop and Apache Spark, they run on Linux systems. And obviously, for everyone to have an access to such a system that can support Hadoop is impossible. So what we're going to do is, what I'm going to do is basically to show you how to install Hadoop on your local computer using this thing called a VirtualBox. So VirtualBox is a virtual computer that you can set up on your computer. So even if you have a Windows machine, you can set up a VirtualBox that contains a Linux operating system. And then in there, we're going to configure a Hadoop environment so that you can log on to that virtual computer, and then you can pretend as if you're managing a real big data system, okay? The second thing we're going to do is we're going to use what is called a Google Collaboratory. And in fact, many of the concepts later on that we're going to study, we don't really need the actual, big data platform. Instead, we're going to practice, how to implement things using Apache Spark. So there's this thing called a PySpark, which is the Python version of Apache Spark. And then we're going to see how to use PySpark to, to address a big data problem. And everything you do on that Google Collaboratory environment is going to be immediately scalable to the actual big data servers. So all of the codes you're going to type and all of the codes that you're going to implement over there are going to be immediately compatible with the big data systems. So that's kind of the action plan when it comes to the practice and the lab sections.
One more follow-up, and I'm sorry to the rest of the class to
No, that's
keep
all right.
asking questions, but-
We're like 25 minutes early, so
all right.
feel free.
It's likely for me when I go back into industry that I will be challenged with some of the solutions like Amazon and Microsoft Azure and the other major providers offer. Are we going to, at any point, at least just talk about what's out there, or is it possible that we could, or that would be a skill or at least some knowledge that would be really helpful at least from my standpoint.
So yeah, that's another good point. And in fact, there are a lot of different platforms like Amazon AWS, for example. Unfortunately, this course is not going to cover all of those details in terms of how to set this up, for example, on Amazon, or how to set this up from scratch on your local machines. We're not going to do that because we're targeting a group of audience who are more data science, statistics oriented, rather than computer science, computer hardware, those kind of topics. But if there's enough interest among among the students, then I'll be happy to maybe upload some bonus clips explaining some those practical challenges.
Yeah, I guess it really wouldn't make sense to do here's how you do it on AWS, for example. What I was, I guess, more inquiring are what are the pitfalls or advantages of what's out there in the market now with some of the major cloud services. Just out of curiosity, but if we get to that point, maybe we can talk about it again.
Sure, yeah. Any other question? Like I said, it's quite early, so I'll be happy to answer more questions.
One more question, Professor.
Hello.
Are we gonna use the Argon system in this class?
No, we're not going to use Argon, but if you already have an access to Argon, then you're more than welcome to use it. But yeah, so it's totally fine. And historically there have been quite a bit of students who already had an access to Argon. So they use Argon for doing their homeworks, semester projects and things like that. So
okay.
Yeah, that's not a problem.
Thank you.
Anything else? Awesome. Then, well, Daniel, were you going to ask some question?
Yeah, I hate to, I'm going to annoy everyone here. There is, I am also enrolled in the machine learning class here at U of I. I suppose some of the material will overlap without question. I don't know that I really have a question here. I'm just more or less making a statement that maybe some of the coursework that I'm going to have is going to be duplicated. But
yeah, there is going to be quite a bit of duplication, especially at the beginning of the semester, because I believe we have a mixture of students with different machine learning backgrounds. So there are actually some students who have not had an experience with machine learning. So for those students, we're going to have some, introductory examples, like linear regression, for example. But I think the discussion is going to be pretty much tuned towards the big data problems. So we're not going to spend, for example, too much of time explaining, I don't know, convergence of the optimization algorithm, you know, those kind of things. Rather, we're going to spend more time on how to make the algorithm more efficient, how to distribute the computation throughout multiple processors, and, you know, things like that.
Okay, thanks.
Sure. All right. Any other questions? Please don't hesitate. We still have 20 more minutes. No more questions? All right, then that's it. Oh, and I forgot to mention, but I'll be posting the video on Icon. So all the lectures are going to be recorded and posted on Icon. So if you cannot make it to the class, you know, then you'll still have an access to the lecture videos. That's totally fine. But I still recommend you to come to the live lecture because, I mean, you may want to interact with me and, you know, ask questions in real time other than watching the videos and things like that. And, you know how things work. I mean, you know, you plan to watch the video tomorrow and then you can, you know, kind of keep postponing that, right? All the way through the end of the semester. So, but anyways, the lecture video is going to be posted online. And I guess that's it. So thank you very much, everyone. It's very nice meeting you virtually. And I'll see you on Thursday.
Thank you.
Thank you.
Happy.
Thanks.